So let's get our notes done. So today we're going to work on solving systems by elimination. This works out really well. I like it better than substitution, but it doesn't always work. It depends upon what the equations look like, how well elimination works, how easy it is, and how difficult it is. Okay. So the idea behind elimination is you create matching but opposite coefficients for a variable and then add the two equations in order to eliminate that variable. So the idea is we want to be able to add the two equations together. When we add the two equations together, something disappears. Okay, and actually algebraically it works really well to solve. I think it's easier. I like elimination, I really do. It works very well. It's easier than substitution. There are times when substitution is easier, like the problems you just had on your quiz. Substitution would work better for that than elimination, but a lot of times elimination works really well. So I'll let you get the rest of that written down.
Add more lines.
You need to write smaller.
No.
I'm kidding.
I like it.
No, I don't either. Just fill in around the blanks around it. You'll be okay.
It looks tacky like that.
Yeah. Hey, I didn't make this up. Somebody else did. I'm just using it. Okay. So, how does elimination work? Okay. So how does elimination work? What you do is you add or subtract the variables. You may have to do a little bit more to make it work. So I look at the first set of ones. And now I'm not solving completely. I'm just going to do the first step to illustrate what I'm talking about. I have in the first set of equations, I have x plus 2y equals 10, 4x minus 2y equals 5. If I look at this, my y, 2y and negative 2y, these are exactly the opposite, plus 2 and minus 2. Whenever I have a variable that has something like this, where I have the coefficients exactly the opposite, what I can do is add the two equations. It doesn't want to write the add. There we go. Add the two equations. Okay. So x plus 4x means that I have 5x. 2y plus negative 2y, my y's cancel. No more y's. 2 minus 2 is 0. 0 y's. Bring down the equals. 10 plus 5 is 15. Now, I'm not done. This is just the first step. I'm only doing the first step here. We will do more when I do the example later. But this is the idea behind elimination. I eliminated my y's. Sometimes you eliminate x, sometimes you eliminate y. On this one, I eliminated the y's. Look what I have, 5x equals 15. That's one step to solve for x. Makes it really easy, doesn't it? Okay, this is what I like about elimination. If I look at the next problem, I have negative 3x and positive 3x. Exactly the same, or I should say exactly opposites here. Negative 3, positive 3, exactly the opposite on the x's. If I take these two and add them together and add the two equations, negative 3x, positive 3x, no more x's. The x's are gone. Y plus negative 2y gives me negative 1y equals 4 plus negative 14 is negative 10. I've eliminated the x's. Makes it really easy. Like I said, I'm not done. This is strictly the first step. I'm not done solving these. I'm not going to finish these. This is just the first step. Yes? Well, okay, so how would you solve this problem? Divide both sides by 5, right? Here, how many y's do I have? I have negative 1y. Divide both sides by negative 1. Okay? So in the last one, it's a little different. On the last one, it's a little different. I don't have two that are exactly opposite. I have my x's, I have 6 and 3. My y's, I have 4 and 4. I don't care about the numbers, I just care about the x's and the y's. Okay, the numbers kind of do what the numbers do. Okay? Yes? I could subtract. And that's exactly what I would do on this one is I would subtract instead of adding them. If I have two that are exactly the same, I would subtract them. It's a little trickier. Now, and I would subtract. So 6 minus 3. Yeah. 6 minus 3 gives me 3x. 4y minus 4y, no more y's, equals, and this is the hard part. This is where most people are going to screw up. I have 6 minus negative 3. I have 6 minus negative 3, which would be plus 9. Okay. And this is where you're subtracting. This is where the most common mistake is. Now, there is an alternative to subtracting. Okay, I'm going to go ahead and erase the work here because I want to show you the alternative to subtracting. If I have two that are exactly the same, okay, my other option other than subtracting is to multiply the bottom equation by -1 first. And when you multiply by -1, all you do is you change the sign of everything that's there. But multiply through by -1 first, and then add the equations. I get the same thing. I get 3x, no more y's, equals 9. So I can either multiply by -1 and then add, or I can subtract. Students tend to make mistakes subtracting more often than addition. It tends to be where the most mistakes are made, or subtracting. Now, I do the subtraction, but I'm really comfortable with working negatives and positives. I don't have a problem with it. Some students would rather multiply by -1 and then add them together. Either way works okay with me. You'll get the right answer in the end. Okay. Now, like I said, that's strictly your first step, but that's what elimination is. You eliminate. You combine the two equations, and you eliminate one of the two variables. Okay. So let's work this problem here and solve it. So I have 2x plus 5y equals 17. 6x minus 5y equals -9. The first thing I do is, do I have two that are exactly opposite? When I look at that, do I have two variables that are exactly opposite? Yeah, 5 and -5 on my y's. So what do? I add them. And I'm going to do this first. There we go. Give myself a little more room. Add the two equations together. So 2x plus 6x, how many x's do I get? 8x. 5y plus -5y, go on, equals 17 plus -9, gives me 8. Divide both sides by 8. I get x equals 1. Piece of cake. That's what I love about elimination. Finding that first variable is really easy. Finding the second variable, because how many answers do I need? I need 2 answers. Now, to find the second answer, you need to do substitution. Take that 1, plug it into either equation for x. Either one of them. One is a little easier than the other. The one on top. And the reason is because the negative 5y and the positive 5y. So what you do is you take this that you got here and plug it into that. 2 times 1 plus 5y equals 17. That's what you do, is you substitute the answer you got back into either one of the other ones and then solve for y. 2 times 2, that gives me 2. 2 plus 5y equals 17. Subtract 2. I get 5y equals 15. Divide by 5. Y equals 3. And there are my two answers. Okay? I like elimination. I really do like elimination. The first step is the easiest one. Questions on this? Okay, problem number 2, solving a system by subtracting or multiplying one equation. So my first step here is to actually write the 2 equations I need to write. Theater club sells a total of 101 tickets for the play. Student ticket cost $1 and an adult ticket is $2.50. Total ticket sales are 164. How many student tickets were sold? Okay, first thing I need to do is I need to write 2 equations. Yes, Lucas. Yeah, go ahead. Okay. So, 2 equations. One for how many tickets, one for how much money. I have student tickets. I have adult tickets. X for student and Y for adult. How many tickets did I sell altogether? How many tickets were sold altogether? No, that's how much money. How many tickets? 101 tickets. They sold 101 tickets. That means X plus Y equals 101. 101, not 100, 101. 101. 101. Okay. There's one equation. The other equation is how much money did I make? How much money do they get per student ticket? 1. So the number of student tickets, X, is how much money I make off of the student tickets. Okay? How much money do I get for an adult ticket? $2.50. So plus 2.5y, and I'm just going to use 2.5. I know there's a 0 there, but I'm lazy. I don't want to write 0. I don't need to. Okay. That's how much money I made off the adult tickets, $2.50 per ticket. I sell 3 tickets and so on. You take that number times 250. How much money did I make altogether? 164. Those are my 2 equations. One for how much money you made, one for how many tickets you sold. Okay, does that make sense? Now I need to figure out how many of each I sold. Do I have 2 that are exactly the same or exactly opposite? I don't. Not opposite, but I have 2 that are exactly the same. So I have a choice. I can either subtract or I can multiply one of the equations by -1 and then add them. Okay. Here is what I am going to do, is I am going to take the top equation, take the top one times -1, and I'm going to write it underneath the one I already have here. So -1 times x gives me -x. -1 times y gives me a -y. -1 times 101 is -101. You see what I did there? I just multiplied by -1. When you multiply by -1, what do? You just change the sign of everything. Now I have a new system of equations. And what do I want to do now? I want to add them. Okay. If I add these two together, my x's go away. 1x minus 1x, no more x's. 2.5 minus 1. What's 2.5 minus 1? 1.5. 1.5. Equals 164 minus 101. 63. Now you divide both sides by 1.5. And I think that should be 42. I think it should be the life universe and everything. Right? 61 divided, so sorry, 63. 63 divided by 1.5. 42, I was right. Then in my head, I was right. Woo! Y equals 42. I sold 42 adult tickets. Yes.
So like I didn't do any of like the red stuff at the bottom.
Okay, what'd you do?
That's still got the same time.
What'd you do?
I just like added it. I did it times it by.
So you subtracted them? What you did? That works for me. And then you got to here. You got to here, right? You didn't do that, right?
Yeah.
What you did is you subtracted them instead. You still got 1.5 and 63. You're fine. You're golden. You're absolutely golden. Okay? No, that works too. There's more than one way often to solve these problems. I'm showing one way. You did another one that works just fine. Which would you probably did what I would probably do right off the bat anyways. Okay?
You only do the other part if you add them.
Right. So and now this is not my final answer. I still need to figure out how many student tickets. So I have x plus 42 equals 101. Subtract 42 from both sides. X equals 59. Yeah. Yes. Yeah. Which is what I did. Now, the last example problem. Okay, this is the most difficult kind of problem you will have. This last problem is the most difficult one you will have. It doesn't get any harder than this one. Your first question, whenever you're solving a system of equations, the first question you ask yourself is, are there two that exactly opposite? Are there two coefficients exactly opposite? Do I have two that if I add them together, something goes away? That's not going to happen. I add these, I get 7. I add those, I get 5. They don't go away. Do I have two that are exactly the same? If I subtract, will that work? No. So what I need to do is I need to multiply one or both equations. In this case, I'm going to multiply both. So, in this situation, no momento, por favor. 1 through 8. 1 through 8. Good luck. Sorry, she's leaving. No, she's just giving it homework. Okay. So I need to decide which variable I want to get rid of, x or y. Here's what I do when I decide what variable to get rid of. If I have one that's positive and the other one's negative, I pick that one. I don't have that. They're all positive. So then the next thing I do is I pick the smallest numbers. And 2 and 3 is smaller than 3 and 4. Not by a lot, but I always use smaller numbers because it's easier. Multiply the top number, the top equation, by 3 and the bottom equation by 2. Do you see the 3 and the 2 in there and the 3 and the 2 in the equations? I get this 3 and 2 from this 3 and 2.
Can you go and do like subtract them and so
No, because you can't do that. You can't combine them up unless you're going to actually eliminate something. If you combine them up and you have not eliminated something, that doesn't work. So you have to multiply them first before you do your elimination. Okay? So you multiply everything in the top equation by 3. 3 times the 3 for the x gives me 9x. 3 times the 2 for the y gives me 6y. And then 3 times the 1. Most students, when they make a mistake, that's the mistake they make because they don't multiply by the number by itself. Everything times 3. 3 times this, 3 times that, 3 times that. Do the same thing with the 2. Multiply everything through by 2. 2 times 4 gives me 8x. 2 times 4, 2 times 3y gives me 6y. And then 2 times negative 2 gives me negative 4. And now I have two variables exactly the same. Now I can add, or now I can subtract and eliminate by subtraction. Nine minus 8 is 1. I have 1x. 6 minus 6, no more y's. My y's have gone away. Like that. Equals 3 minus negative 4. 3 minus negative 4. What's 3 minus negative 4? 7. Watch these when you do your subtraction. So x equals 7. How many do I need? I need 2 answers. I got 2 variables. I need 2 answers. Any one you want. One of the original ones, one of the ones you did, it doesn't matter. You can take that. What Lucas was asking is, can I put this 7 into one of these equations I did here, one of these red ones that I redid? Sure. You can put them here. You can put them in the original. You can put them in any other equation you want. You can put that 7 in for any x you want anywhere. I would actually do this top one here because everything is nice and positive to begin with. So I have, using this equation, I have 3 times 7 plus 2y equals 1. 3 times 7, I get 21, plus 2y equals 1. Subtract 21. 2y equals 20. Divide by 2. Y equals 10. 7 and 10. Yes. Thank you. Negative 20, which means I get negative 10. My bad. My bad. Thank you for catching that. And thank you for catching it and pointing it out right away before I rambled on for the next 10 minutes and said, Mr. Orris, I think you made a mistake 10 minutes ago. Oh, my Algebra 2 students have been killing me when I make stupid mistakes like this. They wait till I'm like on 3 problems later before they point it out. Like, no, if I make a mistake, tell me right away. Okay. Questions? And that all got recorded. Okay. I like elimination. I do. I like elimination better than substitution. Sometimes you can't do elimination. Sometimes you have to do substitution. In order to do elimination, one of the keys to elimination, I didn't really talk about that. Let me go back here. Notice, everything is lined up. My x's line up vertically, my y's line up vertically, my equal sign line up vertically, my constants line up vertically. In order to do elimination, everything you have must line up vertically. Your x's, your y's, your equals, your constants. They have to line up. If they do not line up, you cannot do elimination. You will have to rearrange an equation to do that. So like on the warm-up problem we did, where you had y equals and then a bunch of stuff, and then you had x and y equals a number, you can't do elimination on that. Everything has to be lined up. If it's all lined up, you can eliminate. If it's not lined up, you can't do elimination. You have to either rearrange or do something else. Okay? But they have to be lined up for elimination. Like I said, I like it. I like elimination. It's quick, it's easy. It's easier than substitution, but there's sometimes you can't do elimination, you have to do substitution.